Good morning, everyone. Thank you for getting up early. Someone told me that going out in Leon on a Friday night could be a bit dangerous. So, thank you very much for your kind introduction. We cannot see anything on the screen. I don't know whether it is my fault or not. So first of all, I'd like to find out from you if you are aware of dual stack. So only 2 people. So would you please dim the lights a bit? Because I feel like if I was being questioned, I cannot see the audience. Okay, so thank you. Now? Okay, so you know why IPv4 is or not? Do you know what IP version 6 is? Do you know if you have any machines on the internet with an IPv6 machine? Oh, sorry, a machine with an IPv6 address? Have you ever taken a look at whether your IPv6 is active or not? All right, so today we will be talking about dual stack and possible problems that may come from having an IPv6 in all the machines that are connected to the internet. So, my name is Francisco Jesús Gómez Rodríguez. Everyone calls me Fran. And the takeaway message for my presentation is that you have a better understanding of IPv6 and also that you are aware of the problems that you may have in your machines, those machines that have dual stack, and more specifically, an active dual stack. So I think hopefully I will cover all these contents in my presentation that will be lasting for an hour. So let us start. This is the address that we always have had in our computers, and I'm sure that you have seen it, you have set it up, and probably you have kept it in your memory. So the open space for an IPv6 is quite limited. As it has happened in the history of the internet, well, when someone decided about that, we said, well, probably this will last for a long time. But that has started to be a problem. It started to be a problem some time ago. So nowadays we cannot access an IPv6 by asking the provider if the provider doesn't let you do it, doesn't give you access to it. And I think they said, okay, if the IP address that we don't have now, because we are working in the power of 2, let us use a number of IPs that, in principle, it should take a long time before we need more IPs. Therefore, we have the number of IPv6 addresses that are available according to the protocol. I don't know whether there are any mathematicians in this room, and if so, I would appreciate if they could tell me that number. But anyway, I tell you that that is a big, big number. Have you ever done an if config? Everyone has done that. You didn't? Well, I would invite you to come over here to do it, because it is a great experience. All right, I will call you to the stage later on. So this is an if conf. I don't know whether you've seen it or not. This is a machine that I have connected to the internet, and there are 2 IPs. It has a dual stack. It has the protocol IPv4 and 6. You can consume the services of that server by using any of the 2 protocols. So here you see the difference between the representation of an IPv6 and the full one. The full ones are 4 octets, and then the V6 are 8 in hexadecimal. So in the previous slide, we see why they use the hexadecimal. And if they were to represent that in hexadecimal, the numbers will be too big, and apparently it seems to be a simpler representation because it makes it shorter. So here you can see that the addressing that we have in IPv4, we have one IP, but in IPv6 there is a range. You know how you represent ranges in IPv4? Well, it's the same as in IPv6 with a slash. So in IPv6 there are so many IPs that when they are allocating an IP, they are assigning you a range. So -64 has exactly the same number of IPs, and they are for you. The problem is that you have to manage your IPs, more devices, more IPs, more responsibility. So therefore, this is a tool which is good fun, because in IPv6 calc, this helps you get familiar with it. The idea is to minimize the number of characters that you have to type in. And this tool helps you compress the IP. So we see it compressed, we see the full IP. And it is good for you to know the IPs that you are logging on to. So far so good? Can you follow me? Well, could you write? Do you know how to write an IPv6? Could you remember one? Probably not. As you know, I don't know whether you know whether at home have an IPv6 or not. There are only few here in Spain where some tests have been done. In Spain in 2016, I've been lucky enough to participate in those tests, and I had the luck to have an IPv6 at home. Next year, that will become a reality, and we will have IPv6 at home. In the meantime, if you want to do something with it, we can use Tunnel Broker. Tunnel Broker takes your IPv4 traffic to a point, and then from that point onward, your traffic becomes IPv6. It is a tunnel. It is a tunnel. Okay, you start off from IPv4, and then at the exit, you are IPv6. The limitation is that you can use it for testing, but you cannot really end up working with them because they are often free of charge. And well, it is good to play around with it too, and it helps you understand how IPv6 is all about. Now I tell you where we are in terms of deployment of IPv6. So can you tell me how much traffic on the internet is running on IPv6? Any idea? Would you say 90%? 5%? 12%? That's the answer. Well, Google says that, so perhaps this is not true. Well, this is the graph plotted by Google, and the idea is for it to see this trend. There is a trend. It seems that it wants to boom, to boost itself, but not before the providers can make a good profit out of it. We will have IPv6 everywhere. I very much like this map. I don't know whether you have seen it before or not. And here we can clearly see where there is a higher prevalence of IPv6. There is an adoption rate on the US of 16%. In Spain, we are at 0.1%. To be honest, I just don't believe that. I believe that those data are made based on the TLD of the website that we are using, but probably IPv or the hosting that we are using is one located in Germany. And there is one country which I especially like, which is Zimbabwe. Zimbabwe has 50%, 50 times more IPv6 than Spain. And this in the past was very appealing to me. And I said, why in Zimbabwe there is more IPv6 traffic than in Spain? Very easy answer, because IPv6 came later on and they cannot buy IPv4. In Zimbabwe, they just buy the small amount of IPv4s, and because there are no IPv4 left, and then they have to go and buy IPv6. Any questions, any doubts so far? No questions? Okay, we move on. All right, so we'll continue because I will be showing you some demos. Regarding the adoption of IPv6, there is lots of controversy there. So if you go to a conference in Europe, the people from Swisscom, which is a small provider, they tell you that next year they forecast that they will have 30% of the traffic in IPv6, and in 2025, 60% or 100% of the traffic will be IPv6. I believe that it is not as easy as that. You may force your users to use IPv6, but you will need to help them out. When I told you that next year we will have the chance to have IPv6 at home, I can tell you about my experience the day I had it on in my home. They connected me to the mobile phone, and I could see that it had an IPv6 address. Can you tell me the difference between IPv6 and 4 in the range 194? I'm sure someone has the answer. Well, on IPv6, all the IPs can be routed. So all the IPs can be reached from the internet. So therefore, what is the problem? The problem is that when IPv6 is active at home, everything that you connect to your router by default would be eligible to be routed. So that is to say, if you don't take the necessary measures or someone does it for you, at a given point in time, someone will reach your device, a device which has been thought to be somehow protected, okay? I promised that I was here 9 o'clock, and I did some testing, and it went well. Oh, I have all my demos there. Hopefully it works. So this is the graph that I told you before by Swisscom, and this is the forecast, their forecast. And there is another problem for IPv6. Well, before IPv6, we will be having the dual stack, and dual stack is costly for companies that provide a service on the internet, because you need to set up all machines so that they support both NATs and IPv6. I always compare IPv4 with fossil fuels. Ever since I was small and I went to school, someone at the time was already saying oil will be over, gas will be over. We have to do something. We will run out of oil and gas. And then this year, this week, the OPEC has said that they will not be extracting so much oil because there is a surplus of oil in the world. So the first time that I connected to the IPv6, I thought that I was, it was the first time I I got a job, they started to talk about IPv6 because they said that IPv4 was about to be finished. I don't know who is behind it, perhaps the Masons or Illuminati. I just don't know. Well, but in the meantime, up until IPv4 is finished, we have the dual stack. Dual stack means that from now on, many systems will have two IPs. You will have to manage two different IPs. If you are not ready for IPv6, everything that you do on IPv4, perhaps it is not useful at all, because you will have a way to access to your system through IPv6. And now, how many IPv6 are available on the internet now? Well, Akamai will be providing IPv6 to 4 million devices on the network. And these are the steps that will make IPv6 to gain momentum and to be deployed. On the internet, there are very many graphs, or even Facebook runs comparisons between how fast Facebook may go on IPv6 versus IPv4. Well, Facebook is interested on that because many years ago, Facebook migrated all systems to IPv6. They just want to stop paying the hardware providers so that we users can log on to Facebook in countries where there are only IPv4. Right now, because we are in León, I decided to bring this photograph with me. This is like beef jerk, typical from here. Do you know anyone from León here? Well, imagine that you have a company of beef jerk, and everyone likes beef jerk. And then imagine that your business is going very well. You open up a website, you buy hosting, and then to make your services known, and then there comes a time, one day, another person comes to you and says, okay, I want to buy beef jerk, and then they come here to buy it. And then you realize that your markets on the internet can be significant, and then you decide to set up a website. And then you have a small marketplace where you can sell your products over the internet. Everything goes well. And there is a day that you have very many orders and you need to manage your stocks. You also hire a salesperson, a person who is around promoting your product, etc. And then there comes a time that you decide to make an investment on technology. And then you buy a machine internet for your company. You also have a company, you have also a store, a physical store, and then as well as an online store. And then you set up everything, and then you set up the Apache server. Who has started an Apache server in their machines at least once? Okay, all of you. Do you know that the server is started automatically in IPv6 as long as IPv6 is available? When you start the Apache server, automatically, if IPv6 is available, it is started there. And you may wonder why. Why does that happen? Because IPv6 is not a reality yet. A long time ago, everything has been thought to run on IPv6. The problem is us that we do not do it like that. When you call a DNS, then it gives you a register on IPv6. And if you don't understand it, it gives it to you in IPv4. But by default, it gives you IPv6. And the same goes for services. By default, they are started on IPv6. And what will happen if I scan this machine? I will do a demo now to see what happens in port 80. If I do that, I will see it on both IPv4 and IPv6. And then you will go and say, well, no problem. Well, the person working in the store here selling the food is not a problem. We just do that for me. We'll do the IP tablet, and then here that command says, do not let anyone to reach the port 80. Imagine that you are very extreme, you don't want anyone to go there, but that means that we are going to our website and we are filtering only in IPv4 because IP tablet only works on IPv4. So therefore, our system, our internet system would be available on IPv6. We would need to use IPv6 table to close the IPv6. And then you may go and say, well, that only happens to small stores selling beef jerky here in Leon. Well, actually, I don't know whether you can sell beef jerky on the internet or not. I hope so. I think so. All right. So now, are you aware of Mensa? Do you know Mensa? All right, so this is association of people with high IQ. So let me show you something for you to know. All right, so if you want to take the preliminary test, okay, they charge you 10 euros. To pay 10 euros for someone to tell you that you're stupid, well, that's interesting. Okay, joking apart. Well, this is what I got, what I found, but it could have been any other website. So, all right, I think perhaps they should know more about IPv6, okay. Anyway, they have a service which is known as philemon.mensa.es. What does that mean? It means that they have the internet servers. This is an association, and they are providing services. And I guess that those services have to be available to everyone. Imagine that I ask that IP for whatever reason. I know that this is the DNS that provides a service to Mensa. And then I go and ask it, okay, tell me everything that you know about Mensa. Do you know what is a zone transfer of DNS? Could anyone explain it to me? Okay. Don't you worry. Okay, a zone transfer. It means asking a DNS server. Do you know what a DNS server is? A DNS server makes it possible to browse the web. And then you may ask the DNS server to tell you everything it knows about the area it controls. The Mensa server knows about all the names, all the machines that Mensa is using in the servers, and then you can ask it to tell you everything about that. 4 or 5 years ago, it was very typical to do a poor setting of the Mensa server. Therefore, it became really easy to dump all the IPs and internal domains. And you cannot do that anymore. It doesn't let you do that anymore. They tell you that that is no longer available. And what happens if I ask the IPv6 to do that for me? It doesn't give me that info. It doesn't give me that data because that server, which is older than us on the internet, is one of the pillars of the internet. Therefore, it will use all the available RCCs where it says that IPv6 have to be activated, enabled. So therefore, this command here if I call Mensa and we ask philemon.mensa.es and then we say axfr, which is the command for the sound reference. Okay, here it is. But it is returning all the logs, all the registers that are being used on the DNS. So I said that they liked comic strips because one of the names is Mortadelo and Philemon. Well, these are the things that happening. So probably they did not start the firewall. Probably you may don't know that that is running on IPv6, or probably you don't even know that the service has been started or that it is badly set up. So well, it seems that someone knows that it knows about the bad settings. So it means that someone has been touching the settings, but not all the right settings to fix it. And because this presentation is about backdoors, and I say, okay, I want to find any domain names with the name parking on it. And this is the 24hourparking.com. And exactly the same thing happens with this service, but this time it seems that the issue is firewall issue. I just did an nmap. You know what an nmap is? Well, only few of you. I was expecting more hands up. If I do an nmap on this domain name, and then I say port 587, and then I do nmap on the very same domain, but on IPv6, and same port. Hold on. Can you see that I'm writing down the domain? Well, the actual tool takes care of the resolution. So what we are seeing here is that the port on IPv4 is centered. Someone has started the firewall so that no one can access this service. But they didn't do that on IPv6. And here we have one more variable, which is the dual stack. Many perimeter protection systems do not support IPv6. So therefore, you should filter it from the origin. You cannot really do a bad setting and trust your perimeter security measure. Okay, and this is what is happening here. Someone has not set up the firewall well. And let us go beyond that. Imagine that we call that service, we ask about that service. You know what happens on port 6379? You know what RedIRIS is? You know what a tail is? Only 2 of you studied computer science? Oh, 3. Well, a tail is a tail. But in computer engineering, okay, you just set up something or you leave something there for someone else to use it, whether it is a server or a user. And then, well, we said in the past, I said, oh, I left the port open, and then, well, you may have a vulnerability and someone may break into your system. But sometimes if you leave a door open of a port that displays information, that exposes information, well, you may have a problem there. I don't know whether you're aware of this tool. Entela Tower. Only one of you is aware of it? Well, this is a tool developed by a friend of mine. And this tool connects to RedIRIS and asks for all the available information at the points in time, all available information at the tail. Well, I'm glad that I have a screenshot with me so that you can see it. What you are seeing now is a live dump of that tail. Often this type of RedIRIS, the problem is that some people are using it to paste the cookies messages. among services that are managing users. So therefore, the problem is that that person has that system enabled on IPv6, but is not aware of it because it has installed something by default, it has not set it up, and probably is trusting the available firewall on the machine that is using. Therefore, here we have all this data, and you could stop that if you were to implement the same security measure on both stacks. And do you think that this is happening to people who are setting up internet services and they are learning from YouTube? Don't you think that this doesn't happen to everyone? I'm not going to say out the name of the company, but it is a big company. There are many services that many years ago were all the time being discussed in security conferences because people used to leave them open. So one of them was Telnet. Telnet had a huge repercussion, especially for internet providers, because at the end of the day, big old routers, those managing lots of traffic, were managed on Telnet. And now we are logging to a server has the telnet closed and open on IPv6. That's the banner. What is showing us is exposing a Cisco router to the internet through port 23, which is kind of going back to 1989. I don't know whether someone in here in 1989 logged on to the internet, connected to the internet. Well, that router has that framework. We have to be very, very careful because the systems, even if they are old, they will start themselves in IPv6 because for a long time they've been implementing IPv6 even if the operating system is not available. That does not depend on them. They just use it. And now this is a last example, MongoDB. Often all the new internet servers run on IPv6, so we are talking about relatively new technologies starting on IPv6. And what happens here? You have to be careful. For instance, in this case, this Mongo has exactly the same situation. It has filtered the port on IPv4, but hasn't filtered it on IPv6. What does that mean? It means that the database, Mongo database, is being exposed. I don't know what, you know what MongoDB is? Have you ever connected to MongoDB? Even if you don't have credentials, you can ask things. It is not as intuitive as Telnet, but you can log on to it. If you connect to it, this script will connect to Mongo, will ask for information of the servers. First, we'll do that on IPv6 and then on IPv6. Here, this is what it returns on IPv6, and then it gives us all the information of the MongoDB, which is running on that IPv. Do you understand the problem of that? Okay, good. Do you understand that this you don't do at home? Well, we are not doing anything. I'm just asking. I don't know whether it is my machine or not.
Let's see what happens so that I don't make any mistakes when logging onto it. So this is nice. This is a client, right? This one is in Germany, naturally, because if it's Europe, it's Germany. That's the way it is. And what we have here is a static IP. Someone is buying a static IP for a server they are setting up in their own machines, probably for their own company. And still don't know that it's running on IPv6 because it's centered or focused on IPv4. If it were closed, it would be a different problem. But when filtered, it means that they don't know that it is on IPv6. Problem is that if you have an IDS, you don't even see it. And probably when you go for a forensic analysis, you say, who stole it all from me? And you don't even realize that it's been using a different protocol. And you don't know how your information has been exfiltered. Good. So let's move on to our next level. Differences between scanning IPv4 or IPv6. Anyone? Time. It is time. So if you remember, we had a IPv4 range for all the IPv4s and all the IPv6 that were available. If we go back to that slide, difference is quite impressive, right? So you might have used some of these tools for IPv4. Soden, Census. Do they ring a bell? Citamore, anyone? Citamap, sorry, anyone? Maybe the players. So these tools are focusing on IPv4. I don't know if you knew, but Citamap is a project that has allowed simply for anyone to scan, to sweep the whole port that can be enrooted in just 5 minutes. That's what they say. It depends on the version you have. And so now, one day, 1 week, that's what it takes you to scan the whole IPv4. You can ask every machine on the internet and see what ports are open, what services are running. If we were to do it on IPv6, that would not be possible, and that's the problem. If we cannot find out IPv6, then that means we are a bit more safer, right? If they cannot find you, they cannot touch you. So that belief that even CEOs at security companies have, it's bogus. Because sooner or later, your IP will be exposed on the internet for someone to see. Because this is the final purpose of an IP. Have someone connected to your machine, whether it's you or not. Problem here, well, right now, it's so very difficult to find IPv6 addresses or scan the whole IPv6 range for someone to say, let's connect to the IPs that have been deployed in Zimbabwe by whatever operator. That's quite complicated. As a matter of fact, on IPv6, the scanning tools do not support a range, not even a small range, because the smallest range on IPv6, we've discussed it, is IPv4. So it's so very complicated right now to have a simple implementation to scan IPv6 ranges. Actually, many people complain that tools, machines for pen testing, you need to type the addresses yourself because there's not been an easy finding. Again, these are IP addresses on the internet. For local networks, there are the mechanisms. We have the neighbor finding tool that is similar to that for IPv4. And just to close it up, let me refer to Mr. Luca. So he looks like the Spanish actor Santiago Segura. You know, this is the face that comes to mind when you think of him. And Mr. Luca, well, it is a project that I created with a colleague that should have been here but couldn't make it. And we are trying to have that IPv6 map that is not existent now. For some time now, that we've been tired of watching Google Stats and other entities start saying IPv6 that is available, what's not. And we said, it is pointless. Let's scan all IPs and see what the reality of the IPv6 deployment is. Mr. Luca, it is very user-friendly, Soden style. We will compare results with Soden in a minute. Well, only thing you need to do is log in. It is free of charge. Here it is. And if you can certify you're a researcher and send an email saying that what you're going to do is just for themselves and there is no responsibility, we have no responsibility and will not be held accountable for what they do, they will have more privileges. The idea is to conduct a few operations. From here is where I got the examples that I've shown you. Here they are. So this is telnet service for this domain. This is Mongo. So maybe you come up with a search. Are you interested? Anything you would like to know? Anything? Let's do something. Such as all .s domains, right? So these are a series of sites with services running on domains that are .s. Does not mean that IPs are located in Spain. It means the domain associated to it, it's a .s. Doesn't mean that it's lodged in Spain. And I say it out of experience because most of these sites are lodged or hosted in Ireland or Germany, where the IPv6 services are widespread. But you might say, well, someone needs to have sites here in Spain. Yes, there are a few services that are here in Spain. You all see them in Toledo because geolocation is terrible for IPv6, and so it's not as accurate as when compared to IPv4. We can have searches that can be as complex as we want them to be. But we are trying to map the whole IPv6 network in the most practical way possible, because we do not have the resources to map it all. And even if we had them, it would take us so very long. Still, it is very interesting to see how internet services are evolving, and we will post it on our blog, and how there were many services that were available early this year, and now they are filtered. So there are people who are working now hard, and they are focusing on making sure that IPv6 is securized. No search that you're interested in, no enemies you've got. Very complicated what you say. You say, okay, tweet it to me or something, right? So spell it. Atel.gob.ve. This won't be there. This is the Venezuelan telecommunication regulating system. Maybe this one's not been scanned. Well, let's hope they don't ban us from the country. There you have it. We risked it and we were lucky. Hope nothing comes to us. So yes, services are active, and they know services are active because they've been set up. So you can run different tests. Everything that it's done on Mr. Loker is not intrusive. It's just a Solden. So this is a link where we can compare it to Solden to see if it has IPv4 and what's the difference between both. Here, Solden has not scanned it. I don't know if it's out of fear. We can try it if you wish. It is open. Both services are open. Are there any questions? Examples? Any ports that you're interested in? Go for it. From back there, I don't think I will hear you. Question is, how long has IPv6 been implemented? For how long? I don't know how old you're, but maybe you weren't born. Don't think so. Very long. Actually, let me go back to my presentation, because this is a link for RFC. I don't know if you know what it is. That's where the Internet Protocol definitions are written. I think there was one here, this one here. RCC, this discusses the broken tunnel. This is from 2001, and this is a tunnel broken. There might be IPv6 stuff written before 2000. Good. Thank you. Anyone else? And just to finish, I have a new version, so go for questions. Not that you say domains, but what's safer, a .s or .com? What's more secure? I have no clue about computers. With a .com domain, you will pay less, that's all. But what about email? I have 2 Hotmail accounts, .com and .s, but doesn't matter. Domain is a series of characters written into a DNS so that when you ask, you get an IP response. It is an ID. .s, .com, it's kind of to build up sectors on the internet. .s is Spain, .com is world level, but do not think that a domain would be safer than the other. The only thing that brings you security would be the protocol you're using to get connected, to log on. Domain is just the means to get there. So very interesting. What kind of protocols do you implement to look for IPs? Protocol you mean algorithm, right? I cannot tell you. Sorry. Not been published yet, so what I can say is a super distributed system. It's fully distributed. Same as with setmap that you install on your machine and you can do it from home. This one is much more complicated, and let me tell you why. Because not everything's been rooted on IPv6. It's not just having IPv6, but everything has to be rooted, and not all roots are being tracked the way we would like them to. But we will release the way we do it because we are discussing it with different people to see how to improve it and how to build a community to reach out a large enough number of IP addresses to understand that we have a reasonable knowledge of what's out there on the internet. Thank you very much. Good morning. I have a question. For this search on Mr. Lockware, I think you said MDE.S, which is Ministry of Defense? No, that's a mistake. That's for sure. Education. That stands for education, not defense. Close friends to us, actually. Wow. We need to talk to them. So, they are releasing the DNS version, so no, it's not. No problem. No problem. It's just one line. It could happen to anyone. Let me show you. So, you ask about something else. So, non-extradition countries. Nowadays, who does have active IPv6 that can be routable? As you say, it's not the whole internet that anyone can communicate with anyone. So IPv6 access in Spain, that's not much, right? So who does have a reachable IPv6 that can be routed from other neighbors? AT&T and any other large American companies have already implemented it. Then, well, Deutsche Telekom as well. So all large operators on the internet operating in North America and North of Europe, they work on IPv6 and it's been implemented and they offer it to their users. But careful, because many users ask for it. Have you ever called your operator and asked, do you have IPv6? I advise you to do it. So I understand that even if Deutsche Telekom has IPv6 and it's on the US cannot reach because it's not rooted, yes, that one would be rooted. What I mean is, it might not be rooted if it comes from Azerbaijan, from Azerbaijan to Germany on IPv6. That's what I meant. So there might not be so many people paying attention, making sure that all routes are always up to date. IPv6 is still changing, and so for IPv4, everyone is paying close attention to the routes that are available to connect one to the next. The minute something fails, everyone realizes, but for IPv6 it takes longer for people to realize it because there are not so many people who are surfing or browsing through native IPv6. Thank you. So 37 seconds left. There is a timer there. This is example for the new version. This is dual stack, and our new version is focusing on dual stack. This is a graph where you see IPv4, the one that we found, sorry, the IPv6 we found with IPv4. And they are linked through their domain, right? And what you can see here is the difference between IPv4 and IPv6, what we said before. This is a port 23 that you cannot find on IPv4. So just at a glance, we see what you saw before with nmap, mmap and everything else. Here it is all represented. Okay, it is blinking now. So let me thank you for being here, and I hope you've understood something about IPv6 and dual stack. Come to mrlockware.com, log in, sign up, log in, and anything missing there, I will love to get an email from you. Thank you very much.